All right. Welcome back, everyone. It is October 17th, and we're in our second discussion on chapter 2. So let's head over there. And first, does anybody... Oh, interesting. Little colors were added. Does anyone want to give any opening thoughts or reflections on chapter 2, or just bring up some question?
So I could share briefly experience two in comparison to the previous sections. It took me longer for sure, and I had to do more search for more reference material because I think it's the first section that's really starting to introduce the mathematics of the framework. And the first parts where we're discussing variational free energy, which is only taking into account information about the past and the present to compute free energy. This was relatively straightforward. I think the section on expected free energy is a more significant leap, and I think I need to spend more time um, uh, analyzing that and really making sense of that part of the chapter.
Awesome. Thank you. Anyone else want, again, just any part of 2 that stuck with them, or a question they have, or a thought on the role of the low road?
I will just echo the sentiment that I think I finally, got the handle on free energy as a concept, but the expected free energy is still completely impenetrable, making that cognitive leap is still a little bit beyond my reach.
Cool. We can definitely look over it. Okay, at the very small font overview, we have perception as inference. So it's still passive-ish, even though we can discuss that there are some ways that action is related to even what might be seen as passive inference. Background on Bayesian statistics. Example on the background on Bayesian statistics, which we can look at again. But there's an object in a person's hand, and they're updating their beliefs about what they think that object is based upon what they observe. It might be an apple, it might be a frog, and then they see it jump, and they update their belief from thinking that it's probably an apple to probably a frog. That case is carried through in the exact Bayesian setting. And for smaller state spaces and smaller scale computational problems, you can utilize exact Bayes. However, for larger state spaces, you can't always do exact Bayes. And so that requires an approximation method. And variational free energy, or the evidence lower bound, is a common approximation method for doing variational Bayesian inference. Doing approximate Bayesian inference is then mobilized in this particular partition cybernetic setting, which leads to a discussion of action. Still, we're in the cybernetic setting, continuing to discuss like perception and action as part of this unified approximation challenge. Then we get to the real equations. Equation 2.5 and 2.6 are like the two key equations in this chapter. 2.5 is the variational free energy. So here is where we have the ability to build on people's work previously and also make massive contributions with our studying. Here in 2.5, previous cohorts have used the ontology to provide natural language descriptions of the equation. So if this just looks like a lot of symbology, then it may be helpful to read the ontology description of it. 2.5 variational free energy is about beliefs and data. So variational free energy is like the real-time sense-making vibe check. It's very closely related to how surprising incoming observations are given beliefs. Some more discussion on how the KL divergence comes into play. And then it goes from consideration of the real-time variational free energy into the future-oriented expected free energy and planning as inference with equation 2.6. But that's not something that all cognitive systems necessarily do. Not all systems engage in explicit planning. And then there's some discussions about special cases of expected free energy, and that's the end of the low road. So chapter 2 pretty much starts with a simple exact Bayes setting, slides over to the approximate variational case, applies it to cybernetics, and then introduces the two key equations in 2.5 and 2.6, variational and expected free energy. Just to kind of give an overview, but like, so as you have highlighted, like those are the exact things to pick up in the low road. So anyone else want to just bring up any thought or question, or what area can we go to?
Yeah, I think maybe before we move on to the more technical details, I think it's important to highlight the significance of this jump. Like, it's a conceptual leap that was very striking to me, and I think after you spend some time studying this kind of area, it becomes kind of intuition, but this idea of perception as inference, in contrast to what, at least throughout my life, the way that I've thought about seeing things has been this straight transition from objects in the world to this light on my retina, and then some processing through my brain, and then just kind of this image being projected somewhere. But the predictive aspect, the inferential top-down component of it is I think is a remarkable idea, and it's interesting that this isn't, it's not really something that you can tell. At least I couldn't tell just by observing how I look at the world. At least not earlier in my life. So I just wanted to highlight that as an interesting but significant, like a significant leap, I think, in thinking about perception.
Yes. Sarah, and then anyone else.
Hello. I have a disclosure, a comment, and a question. So my disclosure is I read the wrong chapter. I missed 2 weeks, so I thought I'd missed 2 chapters, but obviously I didn't. I did read this chapter, but I read it like 6 months ago, so I'm just flicking through very fast now. So that was my disclosure. My comment is, yeah, I totally get the idea. It's such like a a flip to go from this idea of light coming in your eyes. I remember in primary school being told off for doing it the wrong way, feeling like light goes out, and she's like, no, it goes in. And like we kind of grow up with this idea like we're sensory machines, but then I feel like once you make the flip, it's all predictive. It's really actually hard to go back and like not see it anymore. And then my question was, so I guess it does relate to this chapter, which is lucky because, you know, that's what we're actually on. So like figure 2.5, right? So you've got this idea of the perception and the action. And one thing I've been struggling with is how they're different, right? Because changing your perception is actually an internal action. So you're updating a model. Well, what's that? That's changing a synaptic weight. That's an action, but it's just being performed internally. So one thing didn't realize I was struggling with this till today is why is perception separate to action? And I know like the idea is it's a unified theory of perception and action, but why do we still have those, and how are they different? Am I missing something? So thank you.
Yes. Yeah. Okay. How are perception and action similar and different and related? Okay. And Christoph?
So I just want to say kind of a couple of things. I like this idea of this what Sarah just said about light going out rather than. It reminded me of a quote from Kierkegaard that life has to be lived forwards, but can only be understood backwards. And there's something about the way we explain the world, you know, to ourselves or and others that has this kind of like inversion quality to it, and I can't put my finger on it precisely yet, but I see it as a kind of some kind of universal phenomenon that's lurking there. But about this leap from, you know, perception to inference, I remember one of the earlier papers by Karl Friston. He mentioned something really fascinating, and he mentions the Hubel and Weisel experiments with a cat retina. I don't know if all of you are familiar with that, but they basically were shining light onto cat's retina, anesthetized cat, and measuring response from some neuron there for, you know, measuring electric response. And they found these ideas of receptive fields that responded to various kinds of orientations and so on. And the interesting phenomenon that they couldn't explain was end stopping. So when you have a receptive field, you know, like it will respond to the specific neuron will respond to some specific orientation and specific length of the rectangle that they were projecting. But when the rectangle gets wide enough, it stops. And the question was why, and neuroscience couldn't quite explain this, but sort of, you know, predictive, the sort of predictive framework. I remember Karl mentioned that in one of his papers. It starts to suddenly make sense because kind of in nature you don't really see short lines. So when you're projecting when you're looking at the horizon, it's always a very, very long line. But if it becomes shorter, then it's, you know, it's something that does not occur in nature, and therefore the neuron fires because it actually is a prediction error. So it's kind of fascinating that this inversion of this idea suddenly made a phenomenon, you know, explainable, which I thought was really, really interesting.
Yes. So first, this light coming in and out of the eye. It is really a different view on perception when, as was brought up, like whether we think about, well, there's this unrolling generative model that's getting light touches from the sensory information, getting fine-tuned. That's the sort of like inside out view of experience, as opposed to a sensory processing. I mean, sensory processing, even as a framework, makes it sound like the information is out there and we're going to like process the wheat, separate the wheat from the chaff, and then we're going to end up with like just the real, you know, we're going to have the pixels on the camera, and then we're going to process the pixels and figure out whether it's a cat or a dog. Or even further, like we're going to process the pixels and then we're going to figure out what to do. As opposed to we're going to have this unfolding model about how things are and their likelihoods and what to do. And then we're going to get just light touches from sensory data. And I guess the trip is that if we believe that sensory processing is outside in, the world will confirm our beliefs. I think there's a few truth drops just in the visual experience that help us understand the inside out perception. So the first is the blind spot, which we don't attend to. It's filled in perfectly, even though there's a large patch on the retina that doesn't get that much visual input. Second one is that in the periphery, there are fewer, there's lower resolution vision and there's no color vision. However, in healthy vision, we have color and equal resolution. And there's experiments that show like, actually, well, it is lower resolution in the periphery, but it's not attended to as such. And then we just look over. And then the third aspect is the saccade. So multiple times per second, our eyes are moving. And with active inference, we can understand, okay, it's like when the gaze is fixed, our precision is high and we're paying more attention to visual input. And then right before we're ready to execute a saccade, of course, this is subconscious, precision is alleviated, the eye moves, and then it's like the foot goes back on the gas. So the fact that the blind spot, the periphery, and the saccades are not attended to is very tangible, that just our visual experience is what we generate it to be, with, of course, information coming from what's external, but it's not being processed merely from what's external. Okay, so let's go to Sarah's question here. How are action and perception similar, different, or related? So what's anything that anyone wants to add on this, or there's a few pieces to bring in?
The part about the planning, is that in between, or is that part of action?
Yeah, great question. Well, so Christoph brought up the Hubel and Wiesel experiments with the cat retina and the selectivities in different brain regions. And that actually connects to one of the most cited neuroscience papers, certainly within the ActInf space, which is Rao and Ballard 99, which provided some of the early strong evidence for predictive coding. And so like, well, so in that retina experiment, they had classical patterns, like classical cell types. Oh, this one responds to vertical lines, this one responds to diagonal lines, this one's horizontal, or so on. However, there were these receptive fields, like patterns of activation of visual neurons that were extra classical, like they were not accounted for within a classical receptive field model. And this paper, with empirical evidence and mathematical modeling, established that predictive coding, which is to say like expectations about visual input, were able to account for some of these extra classical phenomena. Andrew?
Oh yeah, I just wanted to say just very generally on the action perception relationship. Active inference seems to take the stance that like we are actively inferring information around us, and so rather than being like passive observers who are just sitting there, we engage in actions in order to kind of impact our perception, such as like you pick something up and look at it, like you can look at it from different angles. All of those are like actions that you're taking. That's my general sense of the relationship between the two, as opposed to some classical view that we're just sitting there, we're taking in whatever this supposed reality is around us. We're not actually doing anything, we're just observers. That's it. I don't know if that tracks.
Yeah, thank you. Jesse, then Manuel.
Uh, yeah, I mean, isn't the two options either you change your mind or you change the world, right, to minimize the free energy? So that's kind of how I see it. Anything that you do that changes the world materially falls in the category of action, where changing your mind is perception.
I guess what I'm struggling with is that your mind is in the world, right? So you say you change your mind, but that's the same thing as changing the world. Like I'm still struggling with the difference, because changing your mind, it's just okay, even if we reduce it to it's changing firing rates, it's changing patterns in neurons. It's not some esoteric mind concept. It's still something physical we're changing. There's an action there to change the synchrony between different brain regions or whatever it is that causes that sort of perceptual switch. But it's not like an esoteric concept. It's still something physical that's changing is what I'm struggling with. But I completely get what you're saying. Like I do agree with that. But then when the smaller and smaller you get, it's like, well, what is changing your mind? It's just a changing weights between neurons. It's changing synchrony. It's changing something physical. Unless maybe this will be the answer and we'll find something metaphysical finally in the brain somehow.
Awesome. Manuel, and then Susan.
Yeah, just to give my 2 cents on this point, I think it's really interesting what Sarah is saying, but in the formalism where the free energy principle comes from, my understanding is, you have to define a dynamical system which has many variables. And for this thing to apply, there has to be a concept of a Markov blanket, which will come later in the book, but it's like you have a separation of variables that do not have direct contact with other variables within the system, only through this layer of interaction. And perception and action are different there in the directionality of the influences. So perception only influences the internal state of the subsystem you care about, but doesn't do the opposite. The internal system doesn't influence the perception states, and the opposite with action. And when you say, like the brain also is taking an action in a physical world, and that's true, Friston seems to mention pretty often how these Markov blankets, I think of them as, the Matryoshka, the Russian doll, many layers of these Markov blankets on top of each other. So a cell, it's doing its own active inference, but it's so it's had its own Markov blanket, maybe defined by its own cellular membrane and whatnot, but it's part of a circuit. And that circuit has now a more functional Markov blanket, and they take actions towards other systems and many scales of this kind of thing. But I think the more precise difference is this of what variables are changing your system versus what variables you change of what is not the system, all defined by what the Markov blanket is, always in the sense that there has to be something that you care about and the rest that you don't care about directly.
Yes, very interesting and important point, which is a simple or a narrow technical difference between action and perception is for a given system of interest that we're just going to focus on, the inbound dependencies are perceptual, the outbound dependencies are action. And then with a different blanket or a different system of interest, a given causal influence might be understood as, well, it was an action for the speaker, but then it was a perception for the listener. So then by taking by swapping a perspective, we might give a different ActInf ontology tag to the same causal edge on a Bayes graph. Ra, and then Andrew.
Yeah, I was thinking a bit about this after I got to figure 2.2 in the textbook, because the figures, they're illustrating this this interface, or this influence that an agent has on the world to generate some kind of observations Y here. And in my mind, the difference between perception and action is, at least based on the formalism that we're given here, is in the access that we have to the hidden states. So out in the world, there's some process, some generative process, as they refer to it, and there's no way to observe though that the hidden states of that generative process. And the hidden states are the causes of whatever observations you have. So, for example, if you see an apple, there's something out there in the world that is generating apple-like observations on your retina. And then inside of your mind, you have you have a generative model of what that process is out in the world, but you actually have some maybe some influence, some more direct influence over that, over the configuration of that generative model. And so even if you take some actions internally to update that model, it's different than like some proxy action that you take to change your observations out in the world. That's as far as the distinction has been clear enough to me, but I think this idea of a Markov blanket, which we'll probably explore more in the high road to active inference, I think that's also a deep and important idea for establishing what it means to be a system, what it means to be a thing that is separate in some significant way, in some statistical way, perhaps from the external world.
Thank you. Great point. Even if we chose to take a kind of active modeling approach to internal action, like through attention, or whether we even conceptualized of learning as action, like just the actual parameter updating of learning, not just like moving around in the world, only through the agent's boundary would the object be intervened upon in the world. It'd be like, if people are watching a movie and they might be doing attentional modulation or something, but they're not intervening with what's on the movie screen, versus an outgoing dependency, which is to say real overt action, then does modify how hidden states change through time. Andrew?
Sorry. Yeah, no, I think everyone just before me largely summed up what I wanted to say. I guess I'll just add another way I kind of think about it is like the inclusion of the idea of preferences, and the generative model carries preferences, and in differentiating the system of interest, like the model, versus the process, whose true states we don't have direct access to, and so on. Like, for me, a human is a generative model. Like, I have preferences or homeostatic set points, or however you want to view those. So I want to keep my hunger low. I would like to get some good sleep. I would like to have a well-regulated body temperature. And while I would say, yes, my body, my mind, and so on are in fact part and parcel with the world, I'm in the world, I don't think that the world around me has the same preferences I do. I don't think it's attempting to regulate my body and maintain my homeostatic set points. I have to engage in action, as well as like attempting to get rather tractable, accurate perceptions of the world around me in order to act and realize my preferences that are, all of these homeostatic set points. Active inference seems to paint the process around the model potentially as just like an entropic, dissipative set of forces that the agent is trying to act against in some ways. And that's not necessarily a big antagonistic picture between us and the world around us, but in some ways, yeah, we do have to kind of fight for our lives, something like that. So.
Yeah, great points. You could specify a generative model where the environment was just at the exact temperature that the agent preferred. Or you could have one where the environment had some regions that were the preferred temperature and some that weren't. And then that would lead to the question of, well, then how would the agent select where to move? And that would take us literally exactly to expected free energy, where pragmatic value would upweight or upregulate policy selection that led to observations aligning with preferences. But again, to this top question, action and perception certainly work together. That is a kind of way pre-ActInf insight that there's this inextricable relationship between perception and action. Like the even the opening quote of the chapter by William James is connecting thinking and doing. However, they're not the same. We've talked about how for a given system of interest, their directions are different across a blanket. They're also modeled as different in the generative model that we specify. Like this is looking to figure 4.3, but perception is going to be loaded in between observations and hidden states. So perception is going to be just from what variables you actually use, it's mediating the relationship between observations and unobserved latent causes. Like here's the thermometer reading, and then here's the estimate of what temperature it is in the room. That's where perception is. Whereas action is seen as intervening in how hidden states change through time. You're not reaching in and changing how the thermometer reading is related to temperature in the abstract. You're actually doing something that modifies how temperature in the world changes through time. And then the thermometer readings might be different later. So action and perception are coming in differently to how we specify the generative model. Susan or anyone else?
Yeah, I mean, so here's how I'm kind of interpreting the planning, and this kind of brings in, you know, the changing your mind versus changing your world. So changing the world, if I'm trying to change my world, then I'm acting on the environment. And if there's and bringing in the expected ambiguity and risk, that's what's emerging. And if I'm not able to reach the expectations of what's changing in the world, then that's going to bring me back to changing my mind. So that planning is the inferences that I have about what my power in the world is. And I think that for me, that's kind of where I bring in the affordances, because what you talked about, Andrew, was I interpreted that as someone feels entitled, that the world's going to provide them, and then they act out in the world as if they're entitled. They may well either have to change their mind, or they're going to get reinforcement that they are entitled. Does that cohere?
Yeah, like if there's a door and one expects to be on the other side of the door, then it's like you try to open the door. Okay, if it opens, then you change the world. And then you proceed on, and as you described, like then that was like confirmed or reinforced. Whereas if it doesn't open, I mean, what?
I got to get back to changing my mind.
Yeah, you can keep on trying, but at some point, if it's not openable, there's going to have to be a belief update that in that moment, at the very least, that door can't be open. Otherwise, it's going to be just, you're going to not drink any water, and you're going to die trying to open that door. It's like there has to be a stopping point.
And
that's-
that brings in the expected ambiguity plus risk.
Yes, let's
the
definitely look
equation.
at this. Yes, we'll look at 2.5, 2.6 and see what where these come in. Andrew?
Hi, multitasking again. Just a quick question. This action perception conversation reminded me, I have some questions about attention and intention. Are those concepts kind of covered or addressed anywhere in active inference or this textbook?
Attention, absolutely, in its more technical parametric meaning of attention as precision, as well as in its kind of broader psychological meaning. Intention, probably more of a nebulous concept. So not to say that you couldn't assign preferences to be intentions. For example, the belief, desire, intention model that's explored in Livestream 46 by Ryan Smith et al., where they associate preferences just straightforwardly they talk about the generative model in terms of the belief, desire, intention, folk psychology model. But in this textbook, it's going to certainly talk about attention, and that's a major topic.
Cool. Yeah, I was just noticing the other day how with your perceptions, there's certain modalities like your sense, your skin sense and your body sense that can be masked in terms of perception in a way that like noise cannot from your conscious experience. And I thought that might say something interesting about the active inference model or the structure in our brains.
Yes. Cool. Yeah. This is 6.2. Here's like different kinds of observations. So sensor fusion setting, and then attention, is it allocated across sensory modalities, or how is it, or where is it distributed across, or within sensory modalities? How are those attentions to observations related to like unexperienced beliefs about the world? Like you're not actually directly experiencing whether there's a jumping frog, but you may experience interoception, auditory, visual. Jesse?
Could you look at, to Andrew's question, could you look at policy as intention? More or less, because, you know, it's projecting a series of actions that you aren't, you know, that you'd like to have happen, but
Yeah, I
aren't.
was thinking that exact same thing.
So there's a quote on page 38, I believe, where they're discussing beliefs over policies as intention, and this is related to the expected free energy formalism. And yeah, I think this is an interesting quote to discuss if people have any thoughts about it.
Nice, great reference there. I don't know if there's too general of a statement, but to go from something that is technical and within the ActInf ontology, and then kind of like zoom out or adapt it to a more nebulous setting, that's on you. Like if you choose to take that interpretation of a given aspect of active inference in a setting, then it'll be valid in the ways that it's valid for that setting, and it won't be the whole story in the ways that it's not the whole story for that setting. However, that kind of a question is difficult to answer in the abstract, because when we're talking about policy selection, we're talking about metronomes and particles of dust and computers and groups of people. So then if someone's thinking, well, intention, I'm meaning like what I experience when I want to do something, then you're already in the case of a given system of interest, at which point it's no longer like a general question about the ActInf ontology. It's more about how you're adapting a term or an equation or something to a given setting. At which point it'll be useful how it's useful, and it'll be not the whole story in the ways that it isn't. Andrew?
Sorry, I never unraised my hand, but I do actually have a comment on that. Related to policy, one thing maybe this is discussed in later chapters, but policy generation, it seems like, at least in these early equations, a set of policies is inferred, but I don't see how policies are generated. Is that discussed or implied somewhere?
Yeah, good question. It connects to the where is planning. So policies, just as a first pass answer, policies are the affordances that are available multiplied by how many or to the exponent of how many time steps the planning horizon is. So if their affordances are up, down, left, right, it's 4 affordances. Over one time step, there's 4 policies that can be selected, up, down, left, right. So for a time horizon of 1, affordances and policies are identical. For a time horizon of 2, you'd have 16 policies of length 2, up, 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 down, up, right, up, left, etc. So in this setting, policies are just affordances over a horizon. So then how do
I'm not sure that really answers it unless affordances are generated, because it just moves the question to affordances.
Absolutely. So how are affordances learned, or how are they provided? So like in the T-maze or something like that, it's like, how does the rat know that it can move up, down, left, right? So first, we're dealing with maps, not territories. So just specifying a given vector of affordances doesn't mean that the rat knows that it can do those affordances or has any kind of like awareness about them. It's just us describing what we've seen the system do. So when we're talking about the policy prior or the habit vector, the prior on affordances, those are something that the modeler infers, not necessarily the system of interest itself. However, it still is the question of interest. Well, how are those affordances known? And what happens when it up, down, left, right, and then all of a sudden up, down, left, right, and raise up, an arm or something like that? Like, how do new affordances come into play? We can express the question in the ActInf ontology, but write it out for a given system of interest. And then I think you'll be well closer to the answer. But certainly you can develop nested models where like there's a context shift that leads to a different set of affordances. But that's a good question. Let's look at 2.5 and 2.6 and just look at their partitionings. Okay. So here's 2.5. And they write that variational free energy. So variational, it just means we're using variational methods. So we're doing approximate Bayesian computation, not exact Bayes, but approximate Bayes, using variational methods. It may seem an abstract concept, but its nature and role it plays in ActInf becomes apparent when decomposed into quantities that are more intuitive and familiar in cognitive science. So these 3 lines are different decompositions of variational free energy. So they differently partition the kind of same pie. In a few ways, the top line is more of a statistical physics decomposition that is most like, for example, Gibbs free energy for those with a chemistry background, whereas the second and third line have more to do with statistics and model fitting. And in both cases, I mean, ultimately in all cases, since they're describing the exact same quantity, but especially in this pure statistical second and third decompositions, it highlights that we're fitting data, but also not wanting to overfit data. And the family of distributions that are being utilized are whatever are used for Q. Q is the distribution that we control from the family that we selected. So if we say we're going to do variational inference on temperature in this room, and we're going to use a Gaussian distribution, so like a bell curve distribution, that doesn't mean that the temperature in the room is actually changing according to a bell curve, or that the thermometer is giving us readings according to that Gaussian distribution. Maybe it has like a long tail, or maybe it has some other distribution, but it means that we are going to have our hands on the knobs of Q and get to the best fitting, which is to say anything wider would be underfit, anything tighter would be overfit. Those are the knobs that we can control. It might be grossly inadequate, but there is a way to fit the best possible Q to a given Y data. And the way to fit the best Q to a Y is with reducing the KL divergence shown here. And that is variational free energy minimization. If you can reduce that KL divergence between the variational free energy and surprise to 0, then variational inference is identical to exact Bayesian inference, because minimizing surprise is kind of like the actual target here. If you minimize surprise, you've maximized model evidence. You know, you're getting new thermometer readings coming in. If you were minimally surprised by those readings, you would have the highest model evidence. You would have the best belief. So instead of trying to maximize model evidence directly with like a hill climbing approach, statistical physics kind of inverts that problem and says, well, let's think about going downhill with a gradient descent. And here is our way to like have a tractable, incrementally improvable approach that we know is going to be moving in the right direction to surprise minimization with variational free energy minimization, which is highly optimizable. Again, doesn't mean that it's going to get exactly here. Doesn't even mean it'll get close. But you will be able to take incremental improving moves, which is kind of shown here. So that's the real-time beliefs, the approximate posterior Q, and the incoming data Y. That's the variational free energy. And again, the first decomposition is more like statistical physics free energies, and the second and third decompositions are more like statistics. This doesn't have anything to do with the future. This is just like a real-time unfolding. Then we get into expected free energy. So expected free energy extends active inference to include a prospective form of cognition, which is planning. So now, rather than just the kind of ball rolling down the hill. Okay, sometimes it jumps left, sometimes it jumps right, but each time its movement is basically dictated or constrained by its local surroundings. So we could talk about that ball having policy decisions or taking actions in some sort of very like real-time unfolding way, but we might not need to appeal to planning. However, we may be interested in cognitive models that have an explicit planning component, like deliberation or consideration of multiple decisions. Again, this isn't to say that that system does planning, just that we're going to make a cognitive model that includes the planning component. Key notation is when there's a tilde, little curvy line, over a variable, that is being used to refer to like a whole time series of that variable over a given time horizon. So now we move from F of Q and Y, variational free energy, to G of pi. So it's different in a bunch of different ways. Expected free energy is looking to the future with these series of expected hidden states and observations that, of course, have not happened yet, whereas variational free energy was dealing with the actual data, Y. We also noticed that expected free energy is taking in as an argument policy priors, not taking in beliefs and data directly, but rather, even though we see the Q and the Y, but what G is doing most proximally is taking in the prior on policy. So this is like a vector of all the possible policies. Again, if it was only one time step, that's the same as the affordances. If it was 2 time steps, it would be like affordances squared. Taking in the prior distribution on those policies and then sharpening or reweighting them according to this. So let's think about the up, down, left, right, 2 time step settings. So 16 policies. So if we had no a priori habit of any of those, they would all be like 1/16th. And that vector would look like 16 tall, and each value would be 1/16th. Or if we always did policy 1 and 2, and then we very rarely did the other ones, it would be like 0.5, 0.5, and all zeros. Or you might put that in a computer as like 0.49, 0.49, and then very small values for things that are rarely done. G takes in that policy prior, and it updates it according to this calculation. And so for people who want to look at the code, that's very helpful to see where exactly this comes into play. It takes in that vector, and then it sharpens or updates it to give more weight, make the policy posterior bigger, where the policy contributes information gain or pragmatic value. Pragmatic value rewards or updates or increases the weighting on policies that bring expected future observations into alignment with preferences. That is the definition of pragmatic value. The definition of information gain or epistemic value is about the difference that you're expected to get depending on the observations that you expect to see. So it's definitely a lot. However, that is what this top and most common decomposition of expected free energy does. And then, as Susan brought up, another decomposition of G is, rather than thinking about what G does as upweighting based upon epistemic and pragmatic value, you could think about G as changing the weighting of policies based upon their expected ambiguities and risk. David, and then Andrew.
Hi. I guess a major a major obstacle for me to understand all of this is literally the mathematical construction of the sentence. So like I for example here, I just don't know what the tilde means in X and Y, or where the C comes from. Just asking because I don't know if somebody has this sense of discomfort not being able to decode what's this trying to tell me. And I don't know if somebody has some good research on how to really understand this construction.
Yeah, thanks for asking. Totally agreed. Hopefully you're in a good resource now, and thank you again for asking. Depending on someone's familiarity with math or computer science and programming, there's definitely a lot of approaches, but the big approach is many coats of paint. Like, coarse grain it, just say, okay, 2.6 is expected free energy, and you can go down fractal rabbit holes for the rest of your life. Or at some point you can just say, okay, expected free energy is about updating beliefs about action. Another really helpful resource that, again, I encourage people to contribute to is the natural language descriptions of the questions. It's a lot easier to read. There's still a lot of terms in here, but the blue terms are ones where we have mouse over definitions. And then also, maybe someone's interested in playing around more with the AI explanations that we used. These may be helpful. Certainly on your own notebook or however, like the notation and understanding, like, Q, approximate posterior, X, hidden states through time, Y, observations through time, pi, policy. It is like learning a vocabulary or a symbol matching exercise. And math's a language, and ActInf is a dialect. So it just is a lot of exposure and hearing about it. Christoph, they pull the equation out of the hat. Yeah, in some ways, yes. Also, the textbook is distilling and summarizing across research, and there are more lengthy derivations elsewhere. The math learning group, again, to the extent that people want to do these activities, there's always been like a more fundamentals of math learning group side, like just like, what does it mean when we have two matrices and then we just like put them next to each other, like what does that mean to multiply them? And then also some people like Jonathan and Ali and others have worked on the derivations of the equations, and Sanjeev Namjoshi's textbook and other resources help. So it's just like, but being in the game is the key enabling step. Andrew?
Yeah, actually kind of related to this. Just one aside, for some of the Greek characters, as soon as I start like memorizing what the pronunciation of the characters are, you find that there is a mapping between like mu and mind. There's some alliteration going on. So that might be a little mnemonic to help. The other thing is, I was wondering with the assignment of like epistemic value to part of these equations, is that a generally agreed upon format within the sort of scientific body, or was that sort of arbitrarily mapped by the researchers putting these equations together? So like those statistical, Bayesian sort of equations, is that like agreed upon as denoting that qualitative term?
In the case of variational free energy, yes, I'd say it's absolutely non-contentious. Variational Bayesian methods or energy-based methods with these decompositions have been in play for decades. Expected free energy extends VFE into the discussion of observations that have not happened yet. Also, these are non-contentious decompositions, I believe. I don't know. I don't have any survey data on who knows or believes what, but I don't think that these are contentious. About the LaTeX, if there is a column here, if you want the raw LaTeX, that is a good technique. You can paste this into, yeah, GPT-4 can use images as input. This is why the stigmergy is so important. The notes that people write and the questions, like the more that people add, the more material there are for human and non-human learners. And we make do and we stay in the game with what we have. Like 3 or 6 months ago, when we were converting them all to LaTeX, this was the best that we could do. And it works really well with Coda AI. Coda AI does not have the image recognition yet, but if/when they do, we'll be able to add another column and just say, okay, given what's in the figure, ... So yeah, a lot of different interesting emerging ways to work with the material. Cool. So that is chapter 2 on the low road. For the next 2 weeks, we'll head into chapter 3 on the high road. So thank you, everyone. See you next time.
Thank you.
Thank you.
Bye.
Thank you. This is great.